Ready, set, success. That's what we're going to do. Again, you should have gone through all the sections of the homework. We've got the lecture videos, watch those. We've got class videos where we work through a lot of the problems, a majority of the homework problems. Look through those. I have the printed exam 2 review and videos, solution guides for those. Work through it, watch the videos, or watch the videos and then work through it, but again and again. And remember, once you work one once, go back. Now that you know how to do it, work it again. That emphasizes those pathways that you're creating in your mind, those tendrins and dendrites and synapses are no longer going to be lapsing. This is the brain theory that works for us. Okay, I'm going to do the WebAssign review. My suggestion is to work through it as best you can. Come watch these videos. I'm going to work through them, not as if I'm teaching it, but how I would do it working through. So this is kind of a next level review. We will just kind of work through them, and if you need more explanation, go back to the lecture, go back to the brief reviews that I do for each of the other printed review for exam 2, and this one I'm just going to kind of try to go as directly forward as I can. This is where we can build up some speed to ensure we have enough time to take the exam and do everything in it. So don't drop your pencil like that. Okay, so let's start with number 1, and here we are asked to calculate the derivative sure why it's not working. There we go. Oh, I have to be over here, that's why. Okay, now I'm in the right place, I think. Go to draw, get my pencil. Okay, so we want to find the derivative of this function. This is going to be a chain rule. Now we take the derivative of the inside times the derivative of the outside. So the inside part is the derivative is, so we're looking at 2x plus 8. Derivative of 2x is just going to be 2. Derivative of 8 is 0. Okay, so that's the inside part. That's its derivative. Times the derivative of the outside part. If we look at this exponent, it comes down in front. So 0.5. Putting it in the answer box. I probably shouldn't be doing that at this point because we're going to simplify it. So that comes down in front. Nothing happens inside. 2x plus 8. And we subtract 1 from this exponent, so we get a minus 0.5. Let me get that. 0.5. Okay, that's it for the outside. 2 times 0.5 is going to give us 1. So that actually becomes just 1, and it's going to disappear because we don't need to have 1 in the front multiplying. This is a negative exponent, so you may see this answer either as 2x plus 8 to the minus 0.5, or you may see it, again, it might be a multiple choice question, as 1 over 2x plus 8 to the 0.5 now that it's positive. Or there's another way you might see this. Remember the 0.5 power is a half power. It's actually a square root. You might see the multiple choice answer as this. Okay, and while it looks like all that happened was sort of the derivative of the outside, it's because the derivative of the inside came 2, and these guys became a power of 1. Okay, so one of these 3 answers, all of these 3 answers are correct. You'll see one of them on your multiple choice, if it is multiple choice. If not, you just go ahead and enter it in. Okay, so let's see. I'll try to keep moving, but again, you can always fast forward the video if these aren't the questions that you're working on, but I do want to go slow enough for those who need it. Okay, again, chain rule. We take the derivative of the inside function. So x squared is, the derivative is 2x. minus 3x, the derivative is going to be just minus 3. And the derivative of 1 is 0. So that's the derivative of the inside. Now we multiply this, multiply times the derivative of the outside. I take this exponent and bring it down in front. So I get a minus 7 out here times all the inside stuff with nothing happening to it, x squared minus 3x minus 1. And I subtract 1 from the exponent. Now negative 7 minus 1, that's going to give us a negative 8. Okay, so this is a perfectly good answer. You may see an answer where this is distributed in front. Okay, so this is correct, but I want to prepare you. Multiple choice is a great way to take it, but oftentimes the multiple choices, they have had some algebra done to it, so you need to be able to recognize where did they stop. Okay, so they might have the 7 coming through, and that would give us negative 14x plus 21. And then again, they could just have it times this, or because it's a negative exponent, they might rewrite it like this to the positive 8. So this is a correct answer. The answer above it is also correct, but again, you've got to look for, you've got to match up what the correct answer is. They won't show you both of them because they're both correct, but one of these would be in a multiple choice. Again, there are 5 multiple choice questions on here. Okay, let's keep moving. And I'll do 10 at a time, and then I'll take a break because I need a break. Okay, so calculate the derivative. This is very much like it, but it's not set up quite right for us to take this derivative. So we're going to bring we're going to make this negative 2 power. We're going to make it, or this 2 squared power. We're going to move it up and make it negative. So we're going to rewrite this as, we're going to rewrite this as 4 times x squared plus x plus 1 to the negative 2. Okay. Again, I like to take the derivative of the inside part first, so let's go here. We get 2x plus 1. Derivative of 1 is 0. So that's the derivative of the inside part. Boom. This 4 is a constant multiplier, or whatever they call it. It just tags along for the ride, is what it just stays there. And now we take the derivative of the outside part. So we're going to multiply. The negative 2 comes down in front. The inside stays untouched because it's in its bubble, which is a good thing to think about in this pandemic time. Stay in your bubble, and nothing's going to happen to you, hopefully. And then what do? We subtract 1 from the exponent, so this now becomes to the minus 3. This is a correct answer, but to clean things up, negative 2 times 4 is going to give us negative 8. 2x plus 1. Let's go ahead and move this minus 3 down. Again, we don't have to, but it might be what was done. And since it started out down in the denominator, it's very likely that when they do this, they'll move it back down. And then you can also distribute the 8. Again, you don't have to. It's still a correct answer, but algebraically, if it's a multiple choice, we're looking to match up these answers. So minus 16x minus 8. Again, all over this. X squared plus x plus 1. And you just need to be able to recognize it could be any one of these 3. They're all correct, but which one is it? Well, it could be any one of them. Okay, so let's keep moving. Here's another one, chain rule, but we want to rewrite it. What's the square root? That's to the half power. So we've got an inner function of get back over here. We've got an inner function of 5x plus x squared, and it's all to the 0.5 power. Let's do that. You could do 1/2, 0.5 though. I'll do it that way. Again, we take the derivative of the inside function. That's going to be derivative of 5x is 5, derivative of x squared, we get a plus 2x. So that is the inside derivative, times the outside derivative. The 0.5 comes down in front, 0.5, times the inside stuff, 5x plus x squared, and then subtract 1 from the exponent. So when you subtract 1 from 0.5, you get negative 0.5. And then just to clean it up, we can move this whole part with this negative exponent into the denominator. So I'm going to rewrite it, and I can turn it into a square root because that's what we had. 5x plus x squared. Okay, and in the top we can distribute this 0.5, so 5 times 0.5 is 2.5, plus 2 times 0.5 is 1x, or just x. So this could be a very likely answer that you see. Again, it might be left in the one above it, so just be able to recognize. That's what you've got to be able to do with multiple choice. There's going to be multiple levels, and before you simplify, take a look at the answers. Compare all the answers if it is a multiple choice one, and you might not need to simplify it. It might be just what you've already got. If it isn't, go ahead and simplify, and you may see that. Okay, that's the fourth. I'm going to go to the fifth. Looks like I need to give myself a little bit of room here. Okay, so here is a chain rule again, and it's a chain rule with a quotient rule inside here. So when I go to take the derivative of the inside, I've got a few complications. So I've got a over b, and when I take that kind of a derivative, I'm going to take the derivative of a times b minus a times the derivative of b. Okay, and multiplication, we can switch the order, we know that. And then in the denominator, we're going to have just b squared, no derivative of b, just b squared. That's going to be the derivative of the inside part, and then we multiply by the derivative of the outside part. So what is a? A is 3x minus 6. B is the denominator, 2x plus 8. The derivative of a is just 3, and the derivative of b is just 2. We put that together in with this little formula. That's our inside derivative. So derivative of a is 3 times b unchanged, 2x plus 8, minus a, 3x minus 6, times the derivative of b, all divided by b squared, which is 2x plus 8 squared. We're going to multiply that times the derivative of the outside. So this 3 comes down in front, so we got times 3. The inside stuff's in its bubble, it does not change. 3x minus 6 over 2x plus 8. And then the exponent, we subtract 1 from it. 3 minus 1 is 2. Okay, now this is a correct answer. However, it might be simplified. But again, check to see if you see this as your answer. If you don't, well, let's go ahead and remember, there's sort of like a big parentheses around this. So let's go ahead and distribute the 3 and then distribute the 2, because oftentimes we get a bunch of canceling out. So we get 3 times 2 is 6x, 3 times 8 is 24, and then we get, and this negative is going to come through, so we get a negative 6x. See, that's going to cancel out, and then a negative times a negative is positive. 6 times 2 is 12, plus 12, all over 2x plus 8 squared, and then we've got our times 3, and then we've got this thing right here. I won't rewrite it because I'd be writing on top of my head, right? So I'm going to copy it down, but I'm going to simplify here. 6x minus 6x, that's 0. 24 plus 12, that's 36, right? So we're going to have 36 here, but then we're going to multiply by 3, so I'm going to go ahead and do that. That's going to give me 3 times 6 is 18, carry the 1, 3 times 3 is 9, so there's 108 there. 2x plus 8 squared times 3x minus 6 over 2x plus 8 squared. And I think that's about as good as you're going to, there's a little bit more we could do. We could square the top and the bottom, and then we've got a common denominator, but we're multiplying, so we could write as that to the 4th power. I think I'm just going to leave it like this. Again, if I don't see that, I would look for something that might have 2x plus 8 to the 4th power, because I could see, I could make the top squared and the bottom squared, so I can multiply the bottoms and get it to the 4th. So an alternate way to be prepared is that in the bottom you might get 2x plus 8 to the 4th, right? Because it's the top squared and the bottom squared. And in the top you'd have 108 times 3x minus 6 squared. Again, you could FOIL this out, but I think this is all fine. This is, again, we're looking for potential answers. They're all correct answers. Okay, so I'll keep trying to move along as we go. So number 6 is kind of split here, but here we've got a logarithm. So again, it's a chain rule function. So we take the derivative of the inside. And remember these absolute values here on the logarithm, because the logarithm has to, whatever's inputted into a logarithm has to be positive. And actually it has to be greater than 0. It can't be 0 or negative. So this is a way that allows us to have all x's. Now, since you're having x squared anyway, this x squared plus 6 is always going to be positive. So anyway, the bottom line is, don't worry too much about this absolute value, but you'll see them. Okay, derivative of the inside, 2x, that's it, because 6 is derivative of 6 is 0. And then we're going to multiply by the derivative of the outside. And what's the derivative of the outside? Well, remember, natural log of x, or u, or whatever, its derivative is 1 over x. So in this case, it's going to be 1 over x squared plus 6. Whatever was in the inside, that's where it's going to be. We don't need these absolute values anymore because we're not inside a logarithm anymore. The logarithm is gone. So how should we write this final one? I think just 2x over x squared plus 6. So notice we've got the derivative of the inside times the derivative of the outside. That's all there is to this one. And not too much to worry about as far as simplifying. 7. So I'm going to get 3 more done. So this one's actually very straightforward. It's just a reminder that when we take the derivative of any logarithm of some base other than e, something other than the natural logarithm, we get what I'll call a correcting factor, because it's not the natural number, so it needs an adjustment. And so what we get is derivative of the inside is 1. So I want to, the chain rule still applies. And I'll just let's see here. So the inside part is just x. I'm going to, just to get us thinking of chain rule, derivative of the inside is 1 times derivative of the outside is going to be 1 over x, natural log of 7, natural log of whatever the base is, and that's down here as well. And again, you might see it in front or behind. When we take 1s times this, that's all there is. 1 over, I like to put the x in front, otherwise it looks like the natural log of 7x could very easily. So I like to go like this. Okay. And then that's all there is to it. So now find the derivative of this function. What's happening here? I think something has gone weird on my translation of all this stuff. So there's I think one of these is 9. So I'm gonna work this top one here as 8. It might actually be 9, and then I'll work that as 9. So I'll bring this one down here, 4x squared minus x. So that's the one I'm going to do there. And I think that's what one of these h primes is for. Okay, so we'll do this one up here. Derivative of the inside part, x plus 5. Its derivative is 1. That's the derivative of the inside part. Derivative of the outside part is simply e to the x plus 5. And again, whenever we're taking the derivative of an exponential function, we also get the natural log of the base. But natural log of this base, natural log of e, is 1. So usually you don't see this. Okay, so we're not going to write this one. It's there, it's invisible. We're not going to write this one because that's 1. So the derivative is just e to the x plus 5. That's it. It's its own derivative. Okay, but we did go through the derivative, chain rule. Now, when we go to 9, we'll take the derivative of the inside, and it's going to be a little bit more, right? Because x squared minus x, that's going to be 2x minus 1. That's the derivative of the inside part. The derivative of the outside part is going to be itself, again, because that always happens with an exponential, for x squared minus x. But there's this correcting factor. There's this natural log of 4, which in this case is not 1. It's a number, but it's something that makes it all work out. And so that's our answer. Again, we can, if we wanted, since this natural log of 4 is a number, we could distribute it back over here, or maybe put all the multiplication in the front. Natural log of 4, 2x minus 1. So you could see this in multiple orders. Not 1, x. Okay. So something like that is number 9. Okay, let's go to 10, and then we'll take a little break. I'll go to and then we'll make a video. Okay, so this one is sort of the same thing, but notice we've got a product rule going on here. Is actually what's going to happen. We don't really have to specifically use the chain rule so much because this is to a 1 power and this is just natural log of x. But let's think of this as get back over here. So we got a product rule. We want to think of this as a times b, and the derivative is going to be derivative of a times b plus a times the derivative of b. Okay, so, and in this one, a 5x squared minus x, b is natural log of x. So the derivative of a, 2 times 5 is 10x. Move my head out of the way. Minus derivative of x is 1, so we get minus 1 here. Derivative of b is 1 over x. Okay, that's just the derivative of natural log. Come up a little bit. We're not going to go to 11 quite yet. And so then I just put it in its form. So derivative of a is 10x minus 1 times b, which is natural log of x, okay, plus a 5x squared minus x times the derivative of b. And again, we can, you know, you could write this as a fraction with over the x. Not too much we could do here. We could distribute. I don't see really any advantages in doing either of those, but something like this, and maybe just 10x minus 1 natural log of x plus 5x squared minus x over x. Now that we've done that, I guess we could cancel out an x. Now this x has to cancel with both of these because it distributes, right? So it's 5x squared over x minus x over x. So we get 5x minus 1 over here. Here we've got 10x minus 1 natural log of x. They don't quite, I mean, I don't, if I had 10x minus 1, I could factor that out. I don't see that happening here. Even if we distribute, we're not going to have like terms because we've got this natural log of x. I think it's about as far down as we could really take it. So if you don't see this one in the middle, if this is not showing up as an answer on a multiple choice, just be prepared, oh, maybe they distributed and have it in this form. So again, multiple choice tests can, you know, sometimes we feel happy that we've got it because we just have to pick out the right answer, but oftentimes those answers have been simplified in a way that we might not initially see it with the way we worked it. So we've got to be prepared to do some algebra to get it to match. So this is going to be the end of this video, and again I'll make another set of 10 videos for 11 through 20.